Hey everybody, it's Miss Berry. In this video, we are going to go over section 5.3, which is called Discovering Quadratics. Right, so we've talked a little bit about linear functions, which have the form y equals mx plus b. And in this section, we're going to talk about quadratics. Quadratics are sometimes also called square functions. So quadratics, sometimes called square functions. And their graphs are referred to as parabolas. So you may also hear them referred to as parabolas. Another name that they go by is second degree functions. Right, so all of those just mean quadratics. So let's talk about what a quadratic is. So what is a quadratic function? A quadratic function has the form, so we'll say quadratic functions have the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. All right, so a, b, and c are just numbers, also called constants. Now, graphically, that's sort of the algebraic definition up here. But graphically, I can draw a straight line on here to save my life. Let's see. So graphically, they are called parabolas again. So they are called parabolas. Let me try to write that a little neater. Parabolas. And parabolas look one of two ways. First case is they could look like a U. They could also look like an upside down U. And what determines how the parabola looks is actually the value of A. So whether or not A is positive or negative determines whether your parabola will open up or down. All right, so let's talk a little bit more about that. We'll move this over here. Whoops. Move this over here. All right, so the first thing actually that I wanted to identify for you was there's a special point on parabolas, on this parabola here, which is called concave up. The special point is down here at the very bottom. It's called the vertex. The vertex is very important. All right, and then the vertex is on the top of the graph here. So you can see that depending on whether your parabola is concave up or concave down, the vertex will either be the minimum point. So here you can see it's the minimum, or it could also be the maximum. All right, so the vertex is a very important point when you're working with quadratic functions. And it represents either the minimum or the maximum. All right, and the last thing I wanted to tell you about the graph is that you can figure out if your graph is going to look concave up or concave down by the value of A. So if A is greater than 0, then your parabola will be concave up. And the way that you can remember this is concave up like a cup. So how you can distinguish between concave up and concave down. Concave up looks like a cup. Concave down looks like a frown. So here, if you have a value of a that's less than 0 or a negative value for a, then your graph will be concave down. Okay. All right, so we're going to do lots of different problems with quadratics today. But the first thing that we're going to do is talk about how you find the vertex of a parabola. So let's look at a function, or actually first, sorry, I need to explain to you how we find the vertex of a function, of a quadratic function. All right, so when you are finding the vertex of a quadratic function, there's a formula that you can use to find the vertex. All right, so we'll say vertex formula. Now the vertex is a point. Sorry, third one over here. There we go. The vertex is a point on the graph, which means that it will have an x value or an x coordinate and a y coordinate. So here we'll talk about how you find the x coordinate, and here we'll talk about how you find the y coordinate. All right, so to find the x coordinate, it's pretty simple. You just look at your function, which we already talked about. We'll have the form f of x equals ax squared plus bx plus c. So you take your function here, and to find the x coordinate, you're going to go negative b over 2a. All right, so you take the value of b, negate it, then divide by 2 times whatever the value of a is. All right, and then to find the y coordinate, you just plug the x coordinate into the function. So to find the x coordinate of the vertex, it's just negative b over 2a. Excuse me. And to find the y coordinate, all you do is just take that coordinate that you found for x and plug it into your function. That's going to tell you the y value, or the y coordinate. All right, so this is a very important formula. You will definitely want to have this written down on your index card. Oh my goodness, I don't know what just happened. All right, so make sure you have this vertex formula written down, very important. You should write that down on your index card for the test. All right, so now let's look at an example where we're going to find the vertex. All right, so number 1 says find the vertex of the parabola. This particular parabola is named H. It's not going to change how we do the problem. It's just the name of the parabola. So this parabola or quadratic function is h of x equals x squared minus 2x minus 3. So we're starting off with a pretty simple parabola or pretty simple quadratic function. All right, so we're going to find the vertex. We know that it has 2 pieces, an x coordinate and a y coordinate. The x coordinate, to find it, we're just going to do negative b over 2a. To find the y coordinate, we're just going to plug the x coordinate into our function. Sorry, that's so messy. Trying to draw a straight line, but it does not seem to be working out for me. All right, so let's go over here and find our x coordinate. All right, so let's look at our function. Let's identify what a is what b is and what c is. A is the coefficient on x squared, so a here is 1. B is -2, and c is -3. All right, so if the x-coordinate is -b over 2 times a, so that's -b, so the opposite of b would be +2, divided by 2 times a, which would be 2 times 1. 2 times 1 is just 2, and 2 over 2 is 1. All right, so there's our x-coordinate. So if we're writing our answer here, the vertex is going to be in 2 parts. The first part, the x-coordinate is 1. Now let's find our y-coordinate. So we're just going to plug our x-coordinate into our function. So it's going to be h of 1 equals 1 squared minus 2 times 1 minus 3. All right, so let's go over to our calculator and plug this in. You could probably do this in your head, but we'll do it on our calculator just to get some practice. All right, so we're going to go 1. Focus the camera. All right, so 1. Then you're going to do a little caret. The caret is going to put you in the exponent. So here you can see the caret is right here. So go to the exponent, do the caret. 1 squared, or raised to the second power. Get out of the exponent. I just used the arrow to get out of the exponent. So I use this little arrow button right here. Minus 2 times 1. So I'm going to do a little parentheses. 1 minus 3 is -4. All right, so that's our y-coordinate. There we go. There's our vertex. Right, so that's our vertex. Yeah, I'll be struggling with this pen. Let me try that again. Use a regular pen. There we go. Nope, didn't work that time either. All right, so that's the vertex. All right. So I wanted to tell you how to find the vertex first, because that's part of graphing a parabola. So let's look at all of the steps that you need to complete to graph a parabola. All right, so take a minute, pause the video, and write these steps down. This is something that you may, want to put on your index card. It says the graph of f of x equals ax squared plus bx plus c can be graphed using the following steps. So step 1 is to establish the shape of the parabola. Is it going to open up? Is it going to be concave up? Or is it going to be concave down? And again, we can determine that by just looking at the value of a. If a is positive, the graph is going to be concave up. If the value of a is negative, the graph is going to be concave down. Step 2 is to find the vertex. This is sort of the fancy way of writing the vertex formula, is to use this function notation for the y-coordinate. Step 3 is to determine the x-intercepts, if they exist, by substituting 0 in for y, or f of x, and solving for x. Step 4 is to determine the y-intercept by substituting 0 in for x and solving for y. Step 5 is to plot the vertex and the intercepts. And then step 6 is to connect the points to give a graph of the parabola. All right, so we'll do one of these on our homework here. So let's go through an entire example where we graph a quadratic function. All right, so first we're going to practice finding the x and y intercepts. I wanted to show you an example of that before we actually graph one. All right, so this is number 2. It says find the x and y intercepts of the parabola. All right, so X and Y intercepts of the parabola, and our function here, our quadratic function, is h of x equals x squared plus 4x plus 3. All right, so I'm going to just put a line down the middle here, and we will do our x coordinate, or excuse me, our x-intercept. And then we'll do our y-intercept. Just keep those nice and neat. Okay. So kind of make like a little table just to keep this neat. All right, so let's write down the steps for finding the x-intercept. If you remember from the last page, it said to find the x-intercept, you replace y or f of x. In this case, it's h of x with 0. And then solve for x. And then to find the y-intercept, you just do the opposite. So you replace x with 0. And then solve for y, or f of x. All right, so let's find the x-intercept. So we're going to replace y, or f of x, in our case it's h of x, with 0. So we have 0 equals x squared plus 4x plus 3. Okay. So to find the x-intercepts, there's, or to solve for x, there's two ways you can do this. You can either factor this, or you can use the quadratic formula. I'm actually going to show you the quadratic formula because that method works every time. You can't always factor, but you can always use the quadratic formula. All right, so we're going to say quadratic formula. I have to extend our page a little bit. Quadratic formula. All right, so here's the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the values of a, b, and c, again, come from that definition of a quadratic function, ax squared plus bx plus c. All right, so we are going to move that down a little bit. I think I'm going to have to go here. Let's see. There we go. All right, so let's come up here and use the quadratic formula to solve this. Now, one important thing to note whenever you use the quadratic formula is that you have to have 0 on one side. So all of the expressions have to be on the other side of the equation. We have to have 0 on one side. All the other terms of the expression have to be on the other side. All right, so let's identify a, b, and c in our example. Here, a is equal to 1. That kind of looks like a 9. Let me rewrite that. A is equal to 1. B is equal to 4, right there. And C is equal to 3. All right, so let's plug them into our quadratic formula. We get x is equal to negative b, so negative 4, plus or minus the square root of b squared, so that's 4 squared, minus 4, again using the formula down here, minus 4 times a times c, so times a is 1, times c is 3 all over 2 times a, which we said was 1. All right, so the first thing that I always do is I plug in what's called the radicand first. So whatever's under the radical, that's what I plug in first into my calculator. All right, so let's look at our calculator. All right, so we have, clear this out. All right, there we go. Okay, so plugging in the radicand, what's under the radical? 4 raised to the second power, get out of the exponent, minus 4 times 1 times 3. Enter. So that's 4. Right, so I'm going to take and move this down just so it's out of my way. Let's finish plugging this in. Finish simplifying this. We have x equals negative 4 plus or minus the square root of 4 over 2 times 1 is 2. Okay, we know that the square root of 4 is 2. You could check that on your calculator if you wanted to. All right, so square root of 4 is 2. So we have x equals negative 4 plus or minus 2 over 2. This now gets split up into 2 pieces. All right. So it's getting split up into 2 pieces. The first piece is where we have negative 4 plus 2 over 2. And the second piece is where we have x equals negative 4 minus 4, or excuse me, negative 4 minus 2. Minus 2 over 2. All right, so go ahead and simplify this. All right, so negative 4 plus 2 is negative 2 divided by 2 is negative 1. So that's our first x-intercept. And then our second x-intercept, negative 4 minus 2 divided by 2 is negative 3. So notice how I'm doing that in 2 steps. I plug the numerator in first, and then I divided by the denominator. So that's our x-intercepts. Now let's find our y-intercept. The y-intercept is a lot easier to find compared to the x-intercept. Whoops, I was trying to make that longer. Sorry, I'm trying to keep this neat. Here we go. All right, so to find the x-intercept, let's use a different color. We'll use blue. All right, so the y-intercept says replace x with 0 and solve for y, or f of x. In our case, it's h of x. So we're replacing all of the x's with 0. So we'll have 0 squared plus 4 times 0 plus 3. All right, so we have 0 squared is 0 plus 4 times 0 is 0 plus 3. So all that's equal to 3. So that's the y-intercept. It's just 3. And these again are your x-intercepts. Sorry, I keep pressing the little button on my pen. It messes it up. So those are the x-intercepts. Okay. Now let's do an example of where we have to graph something. Graph the parabola using the 5-step method for graphing quadratics. Technically, it said it was 6 steps, so I don't know where they came up with the 5-step method. But we'll review the method in just a minute. But first, go ahead and write down the function. F of x equals 3x squared minus 12x plus 9. You're going to want some graph paper to graph this. All right, so it's f of x equals 3x squared minus 12x plus 9. So let's review the steps for graphing a quadratic. All right, so step 1, establish the shape of the parabola is opening up or down. Find the vertex, find the X and Y intercepts, plot the vertex and the X-intercepts, or excuse me, plot the vertex and the intercepts, and then connect the points. All right. First, let's determine whether this is going to be concave up or concave down. The value of A here, A is equal to 3. So since A is positive, this is going to open up. We know our parabola is going to open up, concave up like a cup. So now we can go ahead and find the vertex. All right, so remember the x coordinate is negative b over 2a. All right, so negative b here is negative 12. C is 9. So the opposite of b, or negative b, would be negative 12, which is positive 12, over 2 times a, so 2 times 3. So 12 over 6, which is 2. All right, so our x coordinate is 2. Let's write that up here. So the vertex is 2, comma, and then we'll find the y coordinate. All right, so remember, to find the y coordinate, you just take your x coordinate and plug it into the function. So that's going to be f of 2 equals 3 times 2 squared minus 12 times 2 plus 9. All right, so let's plug that in. All right, so clear everything out. 3 parentheses 2 raised to the second power. The parentheses there is very important. That tells the calculator that you're only going to be squaring the 2. You don't want to square the 3. Get out of the exponent. Minus 12 times 2 plus 9. So it's negative 3. So there is your y coordinate, negative 3. You can go ahead and plot that if you want to. So to plot the ordered pair 2, negative 3, we would go to the right 2 and then down 3. So there's the vertex. Now we're going to find the intercepts, and we'll be done. Okay. I think I'm actually going to show you all a little trick to make this a little bit easier. Let's start by finding, if you remember, it was a little bit easier. Sorry, let's see if I can get on here correctly. If you remember, it was easier to find the y-intercept. So let's find that first. We're going to find the y-intercept. So to find the y-intercept, you just replace x with 0. So that's 3 times 0 squared minus 12 times 0 plus 9. 3 times 0 squared is 0, minus 12 times 0 is 0, plus 9. That's just equal to 9. All right, so that means it crosses the y-axis at positive 9. So go ahead and plot that point next. All right, so here's the y-axis. That's the y-intercept. So it's where the graph crosses the y-axis. Let's count up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And the trick I wanted to show you has to do with what's called the Axis of Symmetry. All quadratic functions have what's called an axis of symmetry. All right. So the axis of symmetry is a straight up and down line that runs through the vertex. Let me see if I can fix that. So straight up and down line, it runs through the vertex. And what the axis of symmetry tells us is that instead of finding the X-intercept, we can make our lives a little bit easier by just using this axis of symmetry to find the next point. So if this is your Y-intercept and it's 1, 2 places away from the axis of symmetry, if we go 1, 2 places to the right of the axis of symmetry, there's going to be another point there. All right, so that finds your extra point for you. You don't have to worry about plotting that X-intercept. You don't have to worry about finding the X-intercept. You can just move that axis of symmetry out of the way now. And let's see what our last step is going to be. We've completed step 5, which was to plot the vertex and the intercept. And step 6 is going to be to just connect the points. Let me see if I can make this. Oh yeah, that's going to look great. It's probably going to be easier for you to just draw it on your own paper. But I wanted to make this look neat, so I'm going to use this little function on the Smart Notebook. All right, so put the vertex at the very bottom. Remember, it's going to be the minimum here. Make sure you draw an arrow on both ends of your graph. There you go. There's your parabola. All right, so there's your parabola. All right, let's look at an example on what we call modeling with quadratics. All right, so we have this question here. You may want to pause the video, take a second, and write this down. It says, Pleasantburg has a population growth model of P of t equals AT squared plus P plus BT plus P0, where P0 is the initial population. Suppose that the future population of Pleasantburg, t years after January 1st, 2012, is described by the quadratic model P of t equals 0.8 t squared plus 6t plus 16,000. All right, so here's our model. My highlighter's taking a minute to pop up. And it says, what is the population of Pleasantburg on January 1st, 2024? Round your answer to the nearest person. All right, so there's the model. And we're looking for the population January 1st, 2024. How many years is that after 2012? We could do 2024 minus 2012. That'd be 12 years after they took that initial population. So it says that t is the number of years after January 1st. So that's going to be our value for t, 12. So you just plug in t equals 12. So it's going to be P of 12 equals 0.8 times 12 squared plus 6 times 12 plus 16,000. All right, let's get our calculator. and plug that in. 0.8 parentheses 12 close parentheses raised to the second power plus 6 times 12 plus 16,000. Right, it says to round to the nearest person. So you couldn't have like 2/10 of a person. So this use our rounding rules. If it's below 5, we keep it the same. If it's above 5, we round up. So this would be 16,187. 16,187 is our population in 2024, or our estimated population in 2024. Right, we have one more modeling question. It says, again, you may want to take a second, pause the video, and write this down. It says a projectile is fired vertically upward from a height of 250 feet above the ground with an initial velocity of 800 feet per second. Recall that projectiles are modeled by the function h of t equals negative 16t plus v sub 0t plus y sub 0. Write a quadratic equation to model the projectile's height in feet above the ground after t seconds. All right, so here is the formula for a projectile. So this could be like throwing a ball off of a roof, or throwing a firework from the ground or from the top of a hill. Here, again, h of t represents the height. V sub 0 is the initial velocity. And y sub 0 is the height that the projectile is launched from. So it could be anything as simple as being at the top of a hill and throwing a baseball up in the air. All right, so these quadratic functions, you can see that since the value of a here is negative, they're going to look like this. That makes sense, right? Because it's something, a projectile is being thrown up in the air. So imagine like a baseball. You throw it up in the air, it goes up, it reaches some maximum height, and then it, because of gravity, it falls down. That's where that negative 16 comes from. It has to do with gravity. All we have to do here is just plug in what our initial velocity is and what the height that the projectile was launched from was. So very simple. We have h of t equals, this part stays the same, negative 16t squared, plus the initial velocity was 800 feet per second. So just plug in 800 for v sub 0, plus, so 800t, the t comes from right here. So the t comes from right there, plus y sub 0, the height that the projectile was launched from, was 250 feet. And that's it. You're done. Very simple. Just plugging in numbers. All right. So that is everything for section 5.3. If you need any help with graphing, or you would like to see another example done on hawks maybe, just let me know and I'll be happy to make a video of that. Otherwise, I will see you guys soon. Hope you have a good day.